the learning objective here will be on dilution. What is dilution? Dilution is the procedure for preparing a less concentrated solution from a more concentrated solution. What is a concentrated solution? A concentrated solution is that which has a lot of solute in a limited amount of solvent. So like this right here, in this beaker, that is concentrated. Now, if you count the balls, they're probably the same balls that you have here. Assume those balls are the solutes or ions. The only difference here is here you have more solvent. So more solvent, same number of solute. This is going to be called dilute. So the idea here is that moles of solute, and this is very important, moles of solute is kept constant. Okay? Only solvent amount changes. Okay, so you can go this way by diluting, you can go this way by concentrating, vaporizing off the liquid. So if moles of solute is kept constant, then we know we can play around with molarity and volume, because remember the triangle. Moles equals to molarity times volume in liters, right? So if you increase the volume, the molarity will decrease, keeping the moles constant. On the other hand, if you decrease the volume, keeping the moles of solute constant, the molarity concentration will increase. Right? So we can have initial and final conditions, initial and final amounts and conditions. So we can say if moles equals to molarity times volume always, then if you're keeping moles constant, M1V1, that is initial concentration times final initial concentration times initial volume, must be equal to final concentration times final volume. Both of these should give you the same number of moles because you are keeping it constant. So we can find whatever we're looking for here. So if I'm looking for initial concentration, it's going to be final concentration times final volume divided by initial volume. If I'm looking for final volume, that will be initial concentration times initial volume divided by final concentration, and so on and so on. That is the use of this formula, where I is initial, okay, and F is final. So we are saying moles of solute before dilution must be equal to moles of solute after dilution, and we know that moles equals to MV, which is why we can work with MIVI equals to M2V2, or rather equals to MFVF. Let us look at an example. Example 4.9. Describe how you'd prepare 5 times 10 to the power 2, which is 500 ml over 1.75 molar concentration sulfuric acid solution, starting with an more concentrated 8.61 molar stock solution of sulfuric acid. So see here, we are not changing the moles. The amount of sulfuric acid is constant. So moles is constant. All we are changing here is going to be the volume, because it looks like here we are diluting. And how do you dilute? You dilute by adding more solvent. So volume increases. Moles stay constant, and as volume increases, concentration decreases. Increase in volume equals to decrease in concentration. So we are safe to use the M1V1 equals to M2V2, or rather, if you want, call it MIVI equals to M1V1. So what are we given? It seems like here I'm given describe how you'd prepare. Okay, so I'm given V2 to be equal to 5.00 times 10 to the power 2 ml. How you would prepare, that's where I'm going, over 1.75 molar. So M2, you can call this VF if you want, and you can call this MF. M2, what we need to prepare is 1.75 molar. Okay, I'm also given the initial concentration, Mi or M1, to be 8.61 molar. I need to find V1 or Vi, the initial volume that needs to be diluted. And that's how I'm going to describe my answer. Okay, I know that MiVi equals to MFVF. And since I need Vi, I'll divide both sides by Mi, the initial concentration, and that will help me cancel out the mm. So my V initial is gonna be equal to final concentration times final volume divided by initial concentration. And in this case, my final concentration is 1.75 molar. That is our M2, remember? This is our V2. And then multiply by our VF V2, which is 5.00 exponent 2. And that one is in ml, no problem, we'll work with ml. No, this one does not affect the calculations. Then my initial concentration, Mi or M1, is 8.61 molar. It makes sense, it's higher than 1.75 because you are diluting. You want to go from more concentrated 8.61 to less concentrated 1.75. We need more volume. We'll know we got the answer right if and only if Vi is gonna be way less than our VF. So let's do the math. I know you've already done it. So it's gonna be 1.75 multiplied by 5 exponent 2 equals to divided by 8.61. So I'm getting 101.63 ml, which is roughly going to be 1.01 times 1.02, times 10 to the power 2 ml. That is our volume that we need to dilute to 500 ml. VF here is 500 ml. That's the final volume. Okay. So the volume of stock solution needed to be diluted is about 1 or 2 ml. Now, it's asking me to describe how I would prepare this solution, right? So to prepare this, I'll take 1.02 times 10 to the power 2 ml of initial stock solution having concentration of 8.61 molar. Okay, and then I would then add more solvent to top the volume to 5.00 times 10 to the power 2 ml. And you know you can find the difference. The change in volume here is going to be just the 500 minus 101.63 ml. So topping up here will need, so it will be 500 minus 101.63. So it's 398.37 That's the extra volume that will be needed to top the volume to 500 ml. And that answers the question.